quick. It's on your stuff. You want me to show it to you again?
Yeah.
Let me show you where we have it again. So I forgot. I mean, this is the other. I just forgot to change it in the small emails, but I mean the notification, but it's there also. Let me just share my screen with you. So let's go here. So if you go right here, first we're gonna go to sample syllabus. Okay. Then you go to the notes right here, to this one right here. As you can see, next week is spring break. Today is the 9th. Okay. So your exam will be the 21st. I'm sorry, your review will be the 21st, and then the 23rd is the test. And also at the same time, if you go to this to your module right here, let me go as a student. One moment. Let me just get out of here, go as a student. So you can see the same thing. You as a student, if you also go right here, you can see also the same happen over there. So for test number 2, you say it's due March 28th. Okay? Evidence on March 28th, not next week. And also if you go to your modules, and then you go down to your test number 2, right here, where is test number 2? If you open it up, see right here, it's the March 28th. Did I answer your question?
Yeah, yeah, I did.
Yeah. So the only thing is that the announcement, because I just didn't change the announcement, that's why I say March 14. March 14 is next week, which is spring break. So as I already I forgot to change. But one of you said that, hey, Professor, spring break is not this week. So when I give my schedule, I put the one date. But I fix it the same week, the same night I fix it, and I update the syllabus. And then also update. I said I forgot to update this one, but I'll update tonight, okay? And send to you again. All right. So let me stop sharing that and go back to my notes. Here we go. So here, this is another example. You say, according to data from College Board, the mean quantitative SAT score for female college-bound high school seniors in 2009 was 500. Okay. SAT scores are approximately normally distributed with a population standard deviation of 100. So from there, I can get things that I need. Right here, I notice that the mean is given to me. The mean is 500. And the standard deviation is 100. Okay. Now they want to know what percent of female college high school has scored above 675. Remember, whenever I spoke before, above can be greater than, okay? Or you can say more than, greater or equal to, you can use the same symbol, okay? That means we want another value. I mean, so 1% will be such as X is greater than 675, okay? That's the thing we're going to try to find. Again, another way to express the mean and the standard deviation, we'll have to put something like this. So now we put 500 like this. And then this is the mean, and the standard deviation, we'll put 100 for it. If you see something like that, it means the first one is the mean, the second one is the standard deviation. That's a reminder. Okay. So how do it gonna do that? It's very easy, very simple. I mean, I don't want to say it's very simple to do it just like that by going to a StatCrunch. But let's try to use an approach by using the z-score. I know some of you remember the z-score. So let me just remind the formula for it right here. I already have it there. That's previous class, of course. So again, this is the formula for the z-score. Okay. Here, the formula that we use for the z-score was z. Okay, sorry. Okay, this is previous classes. Just a quick note review quickly. And then that'll be some value x, take away the mean, and divided by the standard deviation. Okay? So that's why we talk about the standard about the z-score. So what we did here, we need to find the z-score for 675. Okay? So if you want to find the z-score for 675, this is the x value right here. So we're gonna say the following thing. You're gonna say, this is the formula again. Then you're gonna say 675, take away the mean, and divided by the standard deviation, which is 100. Okay? Then this is going to be able to give you an answer. I'm sorry, I went over that, which is going to be like, just put it the same thing right for you, which is going to be 175. Okay? So we spoke about it before. And does anybody have any question about that? How to get this z-score of a given value, given that you are given the mean and the standard deviation? Does anybody have any question about that? Again, I put my text on, because this is going to be something we're going to do in the exam. Perfect. So now, thank you for your answer. So we got 175. Okay. So do you guys remember what we said about that 175? I mean, if you don't remember, that's fine, but I can just remind you. Anybody remember what we said about that? What is the 175 we present here? Anybody remember? Okay, that's fine. Anybody remember the question? I mean, remember that? How far? You can say that 675. You can say 675 is 1.75 standard deviation away from the mean. That's why we say. In this case, because the 175 is a positive value, so you're gonna say this is above the mean. If it's negative, we say it's gonna be below the mean. Okay? So that's what I mean. So remember that thing. We need to review this little thing. They are very important. Okay? So let's talk about something else here. So remember whenever we did this thing here, the bear shape, we did something like this. Okay? And we should put those values just as +1, -1, -2. I'm sorry, +2, -2, -3, and then +3. Okay? The middle part, we say it's gonna be 0. And then we say that a 68% of the data I went in one standard deviation. And then we keep going and say the same value. I went in 2 standard deviation or 3 standard deviation. And we talk about the usual value in the past. So this I think we just have to go and look up again. But if you have any question about them again, please ask me after class. okay? But if you do have a question about it right now, you can also ask, okay? So it means that if this is what, and in that case, this is using the z-score, we say this is standard here. If it's standard, that 175 will be located somewhere around here in the standard word. It's like a different word. Then that 175 represent this standard value. Okay. Why I say the standard value? For example, if just like I said last time, if I say how far is 500, which is 500, which is the mean, how far is 500 is to itself. 500. We did say something like it be 500. Take away 500, divided by 100, give you 0. That means 500 is about 0 standard deviation away from itself. That means 500 is the mean. Okay, and then that's 175 is either one of those 10 right here. Okay, so if I'm thinking about it here, as you can see, the 500 is the 0. And if you do the other values as well, you see you got a 800 here, is because this is about 3 standard deviation away from the mean. Okay, so to add it, get the 800 again, you're gonna do 800. You're gonna do 500 plus 3 standard deviation. The standard deviation is 100. That's gonna give you 800. So if you want to do a 2 standard deviation, that's going to give you that value right here, etc. But now we worry about the 675 here. This one here, earlier we say that was the 1.75. Okay. So we just talked about that earlier. That this 500 is zeroing it away from itself, and then we talked about these things before. Okay. Now here, that's the 1.75 that is there, just like I just told you earlier. Here is going to be 1.75, which represent the location of 675, which represent the location of 675 in the standard word, like in the standard values. Okay, so the real value will be 500, 675, but in the standard value, we can say this is 0 and 1.75. 1.75 representing the 675. Okay. So again, this is just to fill out the form. So we just had told you earlier, then you put everything here. That'll be 500 here. The graph is a little bit off short a little bit, but bear with me. So I got a better shape for it so you can see. Right here, see, right here. This is gonna be like 500 is the mean, then 600, 400, etc. Okay, this is gonna be like negative. I mean, it's gonna be like 2 standard deviation away. This is gonna be 3 standard deviation away. That's gonna be I'm sorry, 1 standard deviation away. Let's see, where's that? Right here. That'd be 1 standard deviation away. I mean -1, okay, -2, etc. Okay, and that's what we mean by that. Okay, I know we did that side before. I just want to go quickly over that one, just to remind you that about a couple of stuff. So, okay, so again, this is what it is. Okay, so this one say we're gonna draw a vertical line to the curve. First, yes. So what we remember what we're trying to do again. Let me just remind you what we're trying to do again. So let's go back here to the previous slide. We said that we wanted to find the probability of x greater than 675. Okay, we want to find the probability for that. That's what I want to find. Okay. So what we're going to be doing here, this is a visual representation of what we're going to do. Why is my slide? Okay. Right here. So here, what we're gonna be doing, we're gonna be drawing a line right here. Because say greater than 675, it's gonna be on the right side of the 175. Okay. So you're gonna draw a line to the curve at 675, just above the 675. Okay. So then you can put the corresponding z-score, which is going to be 1.75. Okay. So we want to find the percentage of that. So this is what we have. It goes like this. So let me just use mine so it does look a little bit nicer. Oopsie. Okay, then you got 1.75. So this expression, this graph that you see right here, this one will present P of Z, P of X greater than 675. Or you can say, he also present the same thing. You can say P of Z and the standard road greater than 1.75. Okay. So either is either one. One using the actual values, X, the other which using the standard value. Remember what we said before, whenever you see the Z is standard. Okay, this is standard. So how do we get that again? Let's quickly go back to, because I said I'm gonna let you use a stat crunch. So I'm gonna stop sharing that for a minute. Let's try to get that value using stat crunch again, okay? So let me just stop sharing that for a minute. We're gonna go to stat crunch. So remember, this I'll go to stat crunch again. So let's go back to my notes. Okay, this is my class. Okay, I'm gonna go to right here, my stat lab, and then you open my lab, my lab and my string again. Okay, and then this is stat crunch right here. Okay, you click on the stat crunch. If you're not signed, it's gonna be hard for you to know to use it. Okay, let's load it up. We're gonna open stat crunch right here. So we need to find the probability for Z or X greater than 675. So this is what happened. So let's go here and go to stat. Okay, you're gonna go to normal. Calculators, and then go to normal. Right here. Right here. Can you guys see the shape? Can you guys see that? Yes, no?
Yes, I can see it.
Okay, perfect. So what I'm gonna be doing, I'm gonna put the value inside. I can do two ways. So if suppose I'm gonna use the real values now. Suppose the mean is 500. The standard deviation is 100. Okay, and then you want to find the value for is greater than 675. Remember that here we need to switch as a greater than. Okay, 675. Now the value give you the probability will be 0.04. Okay, that means the shaded region, the one that is shaded in red, will present the probability whenever X is greater than 675. Okay, but at the same time, if you want to use the z-score, and whenever we said last time, if you want to use the z-score, the mean is always 0. The standard deviation is always 1, because this is standard. The location of the mean 500 to itself is 0. That means 0 will be a standard value. The location of 675 to the mean is 1.75. This is a standard value. So I'm gonna be doing here, I'm gonna put 1.75 here. That 1.75 represent the 675 and the standard rule, or in the standard term, okay? So now we say compute, you're gonna get exactly the same answer, okay? But remember, you can either use the real value using stat crunch or using the standard deviation value, using the z-score. But remember, in some questions, they might ask you to find the z-score first. Well, I already show you how to find the z-score using the formula, which is X minus the mean divided by standard deviation. So you're gonna use this formula all the time to get the z-score. Okay, sometimes you have to do things little step by steps. Okay. So any question about it? How to use that question, that area, how to find the probability of something? Any question about that? Any questions? Any questions? Okay. Okay, so thank you. So it's a no, sir. Okay. Then let's see something. What we're going to be doing now is to do the same thing, but going backwards. Okay. This time, what I'm going to try to do is to give you the probability. Then we're going to try to get this the X value. Okay. So let's see what we have here. So let's go all the way down here. I work on those. Okay, this we already did this one just did earlier. So here, with this what happened. This one saying a scholarship committee wants to give awards to college-bound women who score at the 96th percentile or above on this SAT. What score does an application need? That means we want to know what is the minimum score you should have to be qualified. Okay, if I want to do a little graph for that, it goes like this. So 96 percentile, okay, is something like that, right? If I do like a 96%, it's something like this. It's shaded like this. Okay, that'll give you 96 percentile. But the thing is, like, this question is a little bit different. Hold on, give me my pen. Hold on, give me get my eraser. This question is a bit different. You want to know people who have more than that. Okay, so let me just shade it one more time because my, PowerPoint is having acting funny sometime. Again, okay, I'll do one more time. So it doesn't messed up. So whenever I have the shade on PowerPoint, sometimes it's messed up everything. Yeah. Okay, so this one here will present 96 percentile. You can say this is 0.96. Okay, but you want to know which value is there. Okay, what's the minimum value? That means the person can have X or more. It can be anything above X or more. That's what it means. That means what we're going to be doing, it means to find something like this. Probability of X greater than something, okay? Okay, greater or equal than something, I can call it A, something like that. That's what we're trying to find, okay? But they give you 96 percentile. That's the cutoff. Now that XY here will be the cutoff point. The cutoff. Okay. So how do we work that one now? So we have a few questions. I'll say we can also talk about here. This one say, will the SAT test score be above the mean or below the mean? We want to know that. Okay. The 90 percentile of the score, such as 96% of all scores are at or below the score. The 5th percentile is the mean, so the 5th percentile is above the mean. Okay, so this is just an explanation to say that, you notice, remember that when you have this thing right here, the mean is always in the middle. Okay, the mean is always in the middle. So as you can see, of course, this is gonna be above the mean. Okay, because this is the mean right here. Okay, the mean is always in the middle. If it was on the left side, you're gonna say below the mean. All right, let's talk about it a little bit more. Let's go to the notes. Let's see. So again, what we're trying to do here to use is the z-score again to find it out. We also can use the actual values, but now let's try to do the z-score, okay? So this is what we have. So we want to know which value. So if you do the graph of 0.96%, 0.96, it'd be somewhere around here. Okay, so you put a graph right here, somewhere around here, somewhere around that'll be 0.96. But we only want to have the thing that is beyond that cutoff value, X right here. There'll be a cutoff value X right here that I want to know about. I can call it A instead, because I use X for something else, okay? But I want to know this guy, that guy on the right side, okay? Any questions so far? Any question? Okay. So now, what do we do? So this is what we're going to be doing. We have the probability of X greater than, let me see what we can talk about it. Notice that here, they just want to show that is normal. The mean is 500 right here, and the standard deviation is 100, okay? That's the mean, and that's the standard deviation. If you want to do standard, you can also put normal, and then put 0, and then put 1. This is normal standard deviation, okay? This is normal. Okay, so how do we do the question? That's the question I want to know. How do we do it? Again, if you look at the graph, we would like to have the cutoff of it. So the graph goes like this, right here, right here, right here, right here, right here. This one will present 0.96. Okay? So it means that there's a value. Wow, hold on, give me one moment to go PowerPoint. That's best than me up a little bit. It means that the value is sometimes such as X, which is less than or equal than A. So it's a value A, I can call it A right here. And then just as is going to give you 0.96. Okay, 0.96. So we have, or you can, if you want to use, this is, I use A for this called, for the real value, we also can use the z-score as well. But for if you use this, the standard value, you're going to have to do some transformation. Okay, so I'm going to show it to you right after. Okay, so let's use the z-value. So we're going to be using StatCrunch again to find that expression. We're going to do it two-way. We're going to either use the z-value or the actual value, because StatCrunch can help you do that. So let's use the actual value. So this is what happened. So let me go back. Let me share my screen to a StatCrunch. Here, this is what we have. The mean is 0. We fill in standard value, and the standard deviation is 1. Okay. So here I'm going to put the value 0.96. 0.96. And then make sure that I put this one here, because remember what we said before, that kind of expression is only for below. Whenever we do this one, by default is for below. Okay, whenever you do the graph, by default we have the below values. Okay, so if you put 0.96, the A value we're talking about is going to be 1.76, 1.75. Okay, so as you can see right here, so what I did it, I just delete that and I put 0.96. Okay, and I put compute. It's generated the point for me. That'll be 1.76. So I'm going to go back to my notes and keep going. So that's mean that value here I'm talking about here is going to be 1.75. But how do I get the X value? That's my question. How do I get the X value? Remember that we say earlier that Z is equal to X minus X bar minus mu divided by standard deviation. And I remember also we were able to create a formula just as X is equal to, I know if you, well, I asked you to write those formulas as well, but let me just remind how to do it again. Okay, so you multiply both sides by the standard deviation, like this. Okay, and then you're gonna have, this is just a quick review for that. You're gonna have what? You're gonna get sigma times Z is equal to X minus the mean. We would like to find the X. X is the subject we want to know about. So move them into the other side. That's mu plus sigma times Z is equal to X. We like to put the Z first. So let's put the Z first, just like we did before. So X is equal to the mean plus the standard deviation times the Z score times the standard deviation. Okay, so we already know the mean. Okay, we already know the mean, which is 500. We already know the standard deviation, which is 100. So we can keep going. Let me just remind you this thing. We did that part already, the 1.75. We just talked about this one earlier. I just talked about this one earlier. And then we'll come up to this one right here. Okay, so you got X equal to the mean mu plus the Z standard deviation. So you plug the value inside, and then you should be able to get the 675. Okay, so that's the way you should be able to do it. We can also quickly try. This one might not be exactly 100%, but you can also quickly try the other way as well. But let's do this one for now. So what does this one means? It means that for you to get that scholarship thing, you need to have at least 675 as a score, because that's what we wanted to know before. Okay, let me just go back. So again, just like you say, the 1.7 that represents 675. Okay, so you need to have at least 675 to receive the scholarship. That's what it means. Okay, so does anybody have any questions so far? These are kind of quick review, and then I can start looking at a little bit at the some of the questions of the review questions for you, and then we can start to see if you can start contribute them. Okay, and remember that we working on correlation. Probably it's a good time to look at StatCrunch, so we can look it up a little bit how to find the correlation using StatCrunch, also to build the regression line. Right? Have you guys started working on the review sheet already? Yes? No? Anybody started working on the review sheet already? Review sheet for the exam? Can you guys hear me?
Yes, but I haven't. I don't know the rest. I haven't started yet.
Okay. All right, and so we need to do it, okay? Because it's almost time is up. But let's look at a little bit of a few questions on them. So let's look at one of the questions that we have on the review sheet. I'm not going to work all of them, but we're going to have just look up a couple of stuff that we have to use StatCrunch, because I'm going to make StatCrunch available for you to use, okay? But we need to learn how to use it. So you have to work on your own too. So let me share my screen with you again. Let me share the one of the review sheet we have in class. So let me just stop sharing that. And share the classroom. Okay, so let's go here to your models right here. We're gonna look at one of the review questions, which is gonna be test one review. No, we didn't test two. Review for test two. Okay, so let's just a bit higher. These are stuff that you need to remember how to work on, okay? So make sure you look at those things. We can talk about it another time, but I want to quickly go over some of the stuff for you. Here, for example, they give you something like this. They give you that table, okay? You said the table shows the number of hits and number of home runs for 10 randomly selected players from a minor league baseball division. Use the data below to complete each spot. They give you this one. These are the number of hits. We call them the X values. And the home runs will be the Y values. Then the thing says, find the correlation coefficient for the data set. Okay. And then I remember that some of you told me that you are having a problem using the, some of you didn't have the scientific calculator. I heard about that. That's why I decided to use the StatCrunch. But are you guys, if I can ask, how do you think I should find these questions? I mean, we talked about correlation before, but so it kind of weird, right? So what can I do here? Nobody's doing anything? Yeah, we can use some other stuff that we have in class, but this is what happens. So if we're using StatCrunch, it makes things a bit simpler for you to do to find the calculation. Okay, instead of going the wrong way. All right. So what we can do, I will be sharing my screen with you again, so we can see what we can do, how to get it. Also, look what he said right here. He said to find the regression line associated with the hits and home runs. So we're gonna try to do that together. Okay. I know previous was gonna be hard, but we're gonna try to do it together here. So let me share my screen so we're gonna work it out together. So let me share my screen. Oh, I already shared my screen. So I can just go here to StatCrunch. So I'm gonna input the values right here. Okay, this is what I'm gonna be doing. Remember what you're gonna be doing. So one of them will be the X values. The other one will be the Y values. Pay attention because it's gonna help you. So for the X value, you're gonna put what we have. You got 119, 128, 109, 125, 135, 111, 195, 163, 207, 163 again. And then I'm going to put the next one. Maybe 7, 12, 6, 18, 34, 17, 38, 13, 41, 31. Again, I still encourage you to use the TR-84, okay? I encourage you to use the TR-84. But if you have any problem, you can always refer to this one on the side, okay? So how do I get this guy now? How do I get the correlation? This is what we do. You're gonna go to start, okay? You're gonna go down to regression because remember the question say, find the correlation, but also it also say to find the regression line, okay? And that table, you can find both of them, okay? That's why I say to just go there. You're gonna go to regression. You're gonna say simple linear. This is what we learn in class, right? We then learn about the other ones like polynomial, and then the other one have like different shape. We only say that for this class, we're gonna be using simple linear. And then we can just probably talk about the curved ones, but we're not gonna be doing a big study about them in this class, okay? So what I'm gonna be doing is identify my X values. And what are my Y values? And then and this one say, they tell you which one they want to be X, which one they want to be Y, okay? So the first values, set of value, which I put in variable A1, I'm gonna be my X values. So I put X value will be variable one, be just the X values. And the next one should be my Y value, okay? Everything else is like optional. I don't have to do that much, okay? And then I can just go ahead and click. If I want something specific, which you're gonna be doing in the future, but we don't have to do it now, we can do it later. So you say compute. I wanna know whether you guys are able to see that table, because sometimes when I open my new table, a new table, sometimes you don't see it. Can you guys see that table that I just put in right now? Just double check. You guys see that little table that just show up right now?
Yes.
Perfect. Now look carefully. I don't know if anybody can see. Anybody can notice what will the equation? I mean, what will be the R square? I mean the correlation. Anybody can see what will be the correlation? Can you see that? Can you tell me what is the correlation here? What will be the correlation here? Just by looking at the little table, what is the correlation here? I mean, if you look carefully, if you pay attention carefully, it does say correlation right here. See that? Correlation coefficient. It said it right here. Can you see it? So can you tell me what is correlation right now? Yes. Now see, this is a correlation. So to answer the first question that we have here, yeah, let's go back to, so here we're gonna say this is 0.79. Okay, 0.79. So I don't know if anybody remember what can we say about 0.79? What can we say about it? What does it say about the data? What does it say about it? We have 0.79. What do you guys think you say about it? Is it gonna be positive correlation and weak, or I can say positive and strong, or I can say, is it negative and weak, or negative and strong? What do you guys think will be? Let me repeat myself. Okay, somebody say positive and strong. So this is positive. That means the relationship between the two the two set is a positive correlation, and it is strong. Okay, we can say this is strong. Okay, because it's like a little bit close to, it's not below 0.5, something like that. Okay, and the reason I say it's positive is because this is like a positive value. Okay, it can be negative as well. Now let's see if we can identify let me just write the answer for you. This is, you say positive and strong. Thank you very much. Now we want to know the regression line. Remember, the regression line is something that goes like this: is a y is equal to mx plus b, something like that. Okay, So we're gonna look at something that specific, shape, if there's equal sign and plus or minus thing going on. And then, or I can just put, some people like to put like that as well. I can say put y is equal to b plus mx. You also can write that. Either way, it doesn't matter. You just call this is the y-intercept form of a line. Okay, equation of a line. So let's see what we can do on the other side. If you guys can identify for me the regression line. Let me go use my Microsoft again. Go back to StatCrunch. Anybody can identify the regression line. And it's different from what anybody can identify the regression line. What I think it will be. As a clue, we say that the var1 represent the x value and the var2 represent the y value. Anybody can help me with that? I'm still waiting. Are you able to identify from the given data to you? Can you guys identify the regression line? It's something that looks like y is equal to b plus mx. It looks like this. You got the same pattern. Can you identify that? Thank you very much. But it's negative 21, okay? Very good. So here is negative 21. So make sure you put it right in the exam because you can mess it up, okay? So I'm gonna say negative 21.59. Okay, simply 59.7 if you want to. I can just say negative 21.6. Then be plus 0.297. Okay, so put 296, 98. And then it's gonna be x. They put var because they say var1 represents x, and we did say var2 represents the y value. This is your equation line. Okay. So we do have some other equation we can do as well. Let me just put 1 to 2 decimal places, 1 decimal place instead. Here I can say this is 0.3 x, and then I can say this is about y is equal to negative 21.6, something like that. Okay. So this one here, just like you see, this is called the slope m. This is the slope, which is 0.3. Okay. So if you remember what we said in the past, we can always put that number over 1 like this, because this is a rate. Okay, it's a rate. So it means that if there's an increase for 0.3, okay, that if there's an increase for one for 0.3, okay, that's also a heat increase by 1. Okay, so increase. So you guys need to remember this little notes because it's going to be part of the exam. Okay, increase of hormone. Okay, 0.3. There should be also an increase of 1 of heats. So the one of them is say heat, the other one say, let me just go back to the notes. One say heats, the other one say home one. For any increase of 0.3, there's an increase of 1 for heats, okay? For any increase of home ones, you got the same thing for an increase of 1 unit. This is going to be the home one increase because it's a positive value, and this is the heat. There's an increase of heat of 1 unit, okay? Any questions? Okay, notice also if there is no heat at all, the value should be negative 21.6, right? If there is no heat at all, there will be negative 0.26, which doesn't make that much sense in real life, but this is to some extent, this equation is valid anyway. But I mean, as you can see, this if you're talking about some other stuff, which is not part of this class, that equation is significant. But if there's no increase, there's nothing at all, if you don't do any heat at all, then that will be negative 0.6. So how do we say that? You see that if you have 0 heat, if you have 0 heat, which is x equal to 0, okay, then you're gonna have y is equal to negative 21.6 plus 0.3 times 0, which gives you negative 21.6. That's mean you have a total of 21.6, negative 21.6 on 1. I mean, yeah, okay. Some remember, statistics is not the exact science. We try always to express more about statistics. I mean, to express the future, this is to give us an idea of what's going on, okay? But this is also a good estimator, okay? That graph here, based on the data we have, is also a good way to express the heats and the ones together, and the home one together, okay? And then we do, I also remember that you can also plug in value to find predictable values. We talk about it, what would be the home one if you hit this amount. We can do that another time. But right now, I want to go over another example. And I think it's very important for me to go over with you. Let me just clear all of these drawings. Let's look at another example here. Let me see. Let's go down. Let's go down. So we look at the other one after, okay? Here, for example, these are the things we just did earlier. They say that the core ID tests are normally distributed with a mean of 100 and a standard deviation of 15 IQ points, okay? They say, what is score corresponding to an IQ of 140? Okay, what this score represent to this? Here they ask you to find the z-score to 140. So based on what we just did earlier, z is equal to x minus mu divided by the standard deviation. Okay, x is here, right here. This is your x. This is the mean. This is the standard deviation. And then just plug it in, it should give you an answer. Anybody can find me the answer here? What will be the answer in that one? What will be the answer here? $2.6, thank you very much. 2.67, what does that mean? It means that 140 is about 267 standard deviation away from the mean. Okay, that's what it means. In fact, it's about 267 units of standard deviation above the mean. But for somebody's on the street, they probably want to know more, but we can just say something like that. Yeah. So you can say, this is a technical term. We can say 140 is 267 standard deviation above the mean. The mean, which is 100. Okay, there's no which is above the mean. Now let's look at the other question. The question say, what is the probability of randomly select a person? What is the probability on the randomly select person as like below 140? Okay, below the below it means less than. Okay, so it's gonna be P of X less than 140. I will not be doing that one because I just went over that with you earlier today. I have to find it. Okay. And then you should be doing at the same time I'm doing that. You also should be able to go to Start Crunch and try to do them at the same time I'm doing them. Or you can use your TR-84 or TR-83 calculator. Okay. Does anybody want me to do that, or I can just skip it?
Can you do it, please? Don't
Okay.
skip it. No.
Okay, so let's do it together. So I'm gonna go to Start Crunch. Remember, the mean is 140, right? I'm sorry, the mean is 100. The standard deviation is 15, and the X value is 140. So how do I do that? I go to Start Crunch right here. So you're gonna I can just clear those things after. So I can do because I don't really need those things right here. So what I'll do, I'm gonna go to calculate stat. Okay, calculator. Remember, we're doing normal distribution. So we're gonna go all the way to normal distribution right here. And then remember that the mean is 100. Standard deviation was 15. Okay. And then they say less than 140. 140. Okay. And then if I do the math and I compute it, that give you 0.9962. Okay. So I'm going to write it down for you. It's going to be 0.9962. So you can say about 99% of them, of the people who will have an IQ score below 140. That's what it means. 99% of the population, almost 90% of the population, or more than 90% of the population, we have an IQ score below 140. Okay. So what about let me see. Let's look at one of the other questions here. Let's see. Let's clear all of this. Let me see. This one say probably this person will have an IQ above 90. So you can do this one as well, above 90. Let's see. So we're gonna go to Start Crunch. Here, I'm just gonna erase 140 and put 90 because it's above, so I need to use greater than. Okay. It gives me the shape also. That means on the right side of that 90. Okay. Notice it's about 0.7475. It means that about 75% of the populations have an IQ score above 90%. I mean, IQ score above 90. That's what it means. All right. So let's see if we can do one more. So we want to know what percent of the population have an IQ score between 95 and 125. Okay. 125 is pretty decent. So let's see what happens. What percent of population will be considered smart? I'm just kidding. Between 95 and 125. Let's see. So remember what we said earlier, whenever you want to do between, because it's a between, so I'm going to use this one right here. Or you can find them separately and subtract the highest probability from the, subtract the lowest probability from the highest one. But now we're going to do between here. So you say between 95 and 120. Yeah, 120, right? And 95, 125, 125. and then the mean is still 100. The standard deviation is 15. If you compute that, that'll give you about 58%. So 58% of the population, or 0.58, has an IQ between 95 and 125. Okay? So 95 and 125. 58% based on the data set that we have. Okay? That's interesting, right? That's kind of interesting. So that's mean if you have an IQ score really high, above 140, that's something. Okay, that's something. All right, and so we do have. Let me see if I can do. Let's do F instead. This one say, what IQ score represent to the 10th percentile of IQ? I'm sorry. What IQ score correspond to the 10th percentile of IQ scores? Okay, so I can do this one here. So here they give me their percentile, which is they give me 0.10. Okay, they give me 0.10 for the percentile. Okay, like this. So we would have to find which number represented that guy. So let's see. So what we can do, it means find the probability of X, right? Greater from some value. And then that's gonna give you 0.10. So it means that what IQ score will be the cutoff. Okay, something like that. So how can we get this guy? They give me 0.10, give me probability. I know the standard deviation. Also, I know the mean. So it's based to get everything else. So let's see what we can get. So this is what we do. Let's go to cursor. Use the same little graph. We already have my mean, there's 100, and the standard deviation has 15. Okay, let's go back to standard. Okay. So that means 100, standard deviation is 15. So you want to know what number will be here. So what I'm going to be doing, I'm going to erase everything I have here. For the probability, I'm going to put 0.10. Okay. But this time, I'm just going to put something less than equal to. The reason I put less than equal to is because they want that cutoff, that cutoff value of people with IQ of 180 or less. That's what it means. Okay. You want to have a cutoff because this is what I mean. That's why I said before. Whenever we're talking about the 10 percentile, the percentile is the percentage of value less in a data set less than that X. That's why we say. We just say percentile will be the percentage of value that are less than X. We talked about it before. So that percentile value we're talking about will be this number right here. So somebody with an IQ of 80, something like 81, that will be the cutoff. I mean, if you have 80, that's the cutoff. I mean, everything below you'll be about 10% of the population will have an IQ. I can say 10% of the population will have an IQ below 80. 80 or less, something like that. Okay. Does anybody have any questions? Okay, so if nobody have any questions, the next time we're gonna be meeting, we're gonna be going over that with you for you to practice. Remember, I want to point out to you that the review is not the exam. The review gives the idea of what's gonna be on the exam. So whenever you work on the review, don't think it has to be exactly word for words. Okay, so you do your best. You're gonna study the content. We have everything for you. Let me just remind you again, we have everything for you and inside the modules. So for you to practice for your review. Okay. Let me just share again. I already shared that one. So we have everything for you inside your module here to practice for test number 2. So make sure you do the review, and then we'll have other videos available for you to practice, okay? Test number 2, right? You see, I got a bunch of stuff of them. I also give you the answers just so you don't go everywhere. And the test will be available promptly when the time comes, okay? But you can do the review, go over the review. Again, next time we come, I'm expecting so you guys can ask me some questions, okay? So the next time we come, it's going to be led by what you have in mind, and not what I have in mind, okay? You also, if you do have questions about Pearson, you can also ask me, okay? But many want to focus on the exam now, which is the review. Any questions that you have, you ask them to me.
Where is the practice test at?
It's right here on the modules.
The modules. Is it like an actual practice test, or is it just like those reviews?
Just like we did for test number 1, you just click on it. It's a PDF file. You look it up and working on it.
Oh,
It's
okay.
not-
I thought it was like, like a link where it's like it has like practice questions where we can like click on it and then we can review.
No. Yeah. But what happens is like this, I'll give you a PDF file for you to review. And then you also use StyleCrunch while you're working also, okay? That's what I was doing right now. But no, there's no question that you're gonna have like pop up in your questions inside. It's just the PDF file that you have to print and work on it, okay? Again, Maria, I went over that this morning. The date is fine. Again, I want to show it to you, Maria. If you go to a syllabus right here, you see that the exam is due on the 28th, not the 14th, on the 28th, okay? Again, the announcement, because at the beginning of the semester, I put the wrong day for the summer break, not summer break, for the spring break. And then somebody say I had to change it, so I went and changed it the same day. The only mistake I did, I forgot to change that. Again, I'm gonna change it tonight for you, okay? So it's not the 14th, all right? You're gonna be in spring break. You're gonna have fun in spring break. So I don't want to make anybody feel sad on spring break. I don't want to be over anybody's schedule on spring break. Okay, I'm gonna change it right now once I leave.
Thank you, Professor. I emailed you about talking to you. This is Javon.
Okay, Javon.
You told me that we could talk after this class.
Yeah, of course. We're gonna talk in our office out together. So okay, so guys, enjoy the rest of your day, enjoy also your spring break. And then again, if you have any questions, please stay. I will put you in my in a waiting list for me to speak to you. Okay, so Javon, I'm gonna have you only here. I'm gonna put everybody else in a waiting.
Okay.
Okay, what happened, Javon? Hold on. Let me stop the recording. One thing I forgot to do.
1 second.
1 second. Let me just stop the recording.